So today we're going to be talking about factoring in something called GCF, which I'm sure you've heard of before, greatest common factor. So let's first start with a little warm up here. So we're going to simplify each polynomial. So remember when we have a variable or a number in front here, in front of parentheses, we always distribute in and we multiply. So a times 3a is 3a squared, and then a times 7 is 7a. Okay, let's try the next one. So this negative 2m times m squared, we add the exponents. So it's negative 2m cubed. And then negative 2 times 6, negative 2 times 6 is negative 12. And then m times m is m squared. And then we have negative 2m times negative 1. Well, negative 2 times negative 1 is a positive 2. And then just an m. And then our very last one here, we have a 4x cubed times y times x squared. So we can add these exponents here. So it's 4x to the 5th y. There's no y's to combine there. And then here we have a 4 times a negative 2, which is negative 8. And then x cubed, because we don't have any extra x's over here, y squared. Okay, so we're going to do the opposite today. We're going to factor out a GCF. So if you were given this, how could you get to here? So instead of distributing in, now we're actually going to take out a GCF, what they have in common, their greatest common factors, and then we're going to make it look like this. So we're going backwards today. So if we look here, what do they have in common? Well, 3 and 7, there's nothing that go into both of those numbers. So there's no coefficients or there's no numbers in common. But a squared and a, we can take an a out of both of these, right? So you see if we factor out an a, if we take out an a out of this one, we're left with 3a. And if we divide an a out of here, we're left with a 7. Same thing here. If I'm given this to you, what do they have in common? Well, they have a negative 2. Now, can you just take out a positive 2? Yes, either one would be fine. But you know they have a 2 in common, right? All of these terms, each term, there's 3 terms. Each term can be divided by a 2 or a negative 2. Either one is fine. So they decided a negative 2. And then each of these, see m cubed, m squared, and m, they have one m in common. We can take out one m out of all of these. We can't take out two m's because this doesn't have an m squared. This is just an m. So we can only divide out an m out of all of these. So the GCF here is negative 2m. And then we just divide this by negative 2m. So negative 2 divided by negative 2 is just a 1. And then if we take out an m here, we have 2 left. If we take out an m here, we have 1 left. And if we take out an m here, we have none left. And if we divide that by negative 2, it's 6. Divide that by negative 2, it's negative 1. Okay, and then what's the greatest common factor here? Well, they have a 4 in common. 4. They have, out of the x's, they have x cubed in common. We can divide an x cubed out of both of them. And they have a y in common. We can divide a y out of both of them. So that's what we're doing today. We're going from here to here. So what is factoring? Well, it's separating a polynomial back into a product. So it's separating this, and it's going back to this way, this product right here. Okay, and product means multiplication. So if we had something like this, just like if we were going back to this stage, how do we get back over here? Well, what do they have in common? They have a 4. We could take a 4 out of both of them. And they also have an a in common. And then what's left over? Well, if we divide 4a squared, if we divide that by 4, we have a 1 left, and we have an a. And you can think about it this way. If you multiply this back, 4a times a, is that 4a squared? Yes. And you can do that to check. Plus 2, because 4a times 2 is 8a. So you see how we can go from one to the other? So polynomials that cannot be factored are called prime. So if you cannot take out anything out of either one of the numbers, for example, if you had something like 3a plus 10, this would be prime because we can't take anything out of 3 and 10, nothing in common, and they both don't have an a. So this would be prime. Okay? So factoring a GCF. There are several factoring methods. The approach depends on the polynomial. We will start by identifying and factoring out the greatest common factor. So we're going to be factoring in a lot of different ways this unit. So the first thing we're going to start is with the GCF. So to factor out a GCF, first you have to identify the GCF. So check for the numbers and the variables to see what the coefficients or the numbers in front of the variables, like this is a coefficient, and check for the variables. A variable must be present in all terms to be a GCF. So remember when I used that last example, 3a plus 10? There's no a in the second term, so there's no GCF of a. If a variable is present in all terms, this is really important. So let me highlight this really quick. Okay. If a variable is present, take the one with the smallest exponent. So when you're factoring out a variable, so for example, let's just pretend this was a cubed like that. What's the smallest exponent here? Well, the smallest exponent, remember exponent are these little numbers, is a 1, isn't it? So we can take one a out of both of these. So we could factor out an a, and what are we left with in the first term? 3 plus, and if we took out one a here, what's left? Well, we still have a 10 because we haven't taken out any numbers, but we have an a squared. So you see how we get from here to here? So if we have a variable, we have to take the one with the smallest exponent. This is really important. And then step 2, divide each term by the GCF and leave the remaining factors in parentheses. And then step 3, check your work by distributing. So factor each polynomial. Check your work by distributing. If a polynomial cannot be factored, write prime. So let's look at number 1, 3x plus 12. They have a 3 in common. We can divide both of these by a 3. So I'm going to factor out a 3. They both don't have any x. This doesn't have an x term. This does. So we can't take out an x. We can take out a 3, put a parenthesis. What's left over here? Well, if we divide 3 here, we have an x left. And if we divide 3 here, we have a 4. Now let's check by distributing. So 3 times x is 3x. 3 times 4 is 12. So yep. So that means that's these match, which they should match. So that means your answer is 3 times x plus 4. Okay. So the next one, 7y minus 7. What do they have in common? They have a 7 times, if you divide a 7 out of here, you have a y left. And if you divide a 7 out of here, negative 7 divided by 7 is negative 1. And if you distribute back, 7 times y is 7y. 7 times negative 1 is negative 7. So that's your answer. Okay, down here, what do they have in common? They don't have an 8 in common, but they have a 4. We can divide 4 here, and we can divide 4 here. You always want your greatest common factor too. So if you said, oh, both of them go into 2, there's something more than 2, okay? So let's just pretend really quick that you did take out a 2. So before I show you the answer, let's just pretend you took out a 2 and you said 4m plus, and if you divide 2 here by 36, you'd get 18n. Okay, do you notice how, you see how 4 and 18, a 2 can still go into it? That means you didn't take out a high enough number. So if these are still both even, or if you're like, oh, well, actually something still goes into 4 and 18, that means you didn't go high enough because you could still take out another 2. So make sure that you do check that. So you always want to check out the greatest. So they have a 4 in common. Well, if we divide 4, 8 divided by 4 is 2, and we still have an m there. And then if we divide 36 by 4, we get 9, and we still have an n. 4 times 2 is 8m. 4 times 9n is 36n, so that's your answer. And also, 9 and 2 don't have anything in common, so we know we went as far as we could go. That's the GCF then, is 4. Okay, you try number 4. Number 5. Now, I put a star next to this because you might think, oh, that's prime. But don't forget, you can actually divide a 3 by 27, right? So we could take a 3 out of this. So if we divide this first term by 3, what do we have left? 6 divided by 3 is 2, and then a squared. We just bring that down. 27 divided by 3 is 9, and that's your answer. Let's check really quick. 3 times 2 is 6, and then a squared. 3 times 9 is 27, so that means that's your answer. Number 6, you see how it's 4 and 24? What number goes into both of these? Well, we could divide each of these terms by 4. So 4 is one part of it. And then you see these y squared and y? Both of them have a variable. Remember on the first page it said if you have a variable, you take the smallest. So y is the smallest, so we're going to put a y there. Now parenthesis, what are we left with? If we divide this, 4 divided by 4 is 1. Y squared divided by y, remember we always subtract the exponents when we divide, we're only left with 1y. And then minus, and then 24 divided by 4 is 6. And then y divided by y, there's nothing left for the y's. So now let's check. 4y times y is 4y squared, and 4y times negative 6 is negative 24y. So that's your answer. Okay, try 7. Let's look at 8. So what goes into 14 and 18? We always want to look at the numbers first. The only thing that can go into those is a 2. And then notice how this one has a G, but this one doesn't have a G. That means we cannot take out a G from both of them. But we can take out an H. Both of them are the same, so we know we're just going to take out an H, and we're going to put a parenthesis. What's left if we divide this by 2? 14 divided by 2 is 7. And then if we're going to leave the G there because there's no G taken out of it. And then H and H, well, they're the same, so they cancel out. There's no H's left. And then negative 18 divided by 2 is negative 9. And then again, the H's cancel out. There's no H's left. So now we're going to distribute to check. 2 times 7 is 14. H times G is GH. 2H times negative 9 is negative 18H, so that's your answer. Okay, I want you to try 9. Let's look at 10. So 16 and 24, what do they have in common? So if you say 4 or 2, you're right, but they have something even greater in common. Remember, it's the GCF, the greatest common factor, which is an 8. Let's look at the variables. We have b and b, so a b can come out of both of them. And then c squared and c, we always take the lowest exponent, so we're going to take out a c. What's left over? 16 divided by 8 is 2. There's no more b's left. The b's cancel. And we have a c squared divided by a c. We're only left with one c left. Plus 24 divided by 8 is 3. And then actually both the variables cancel. See how BC and BC? If we take out a BC, there's nothing left. So that's it. And let's check. 8 times 2 is 16. B and then C times C is C squared. 8BC times 3 is 24BC, so that's your answer. Okay, let's try 11. So notice 11, both of them have A's in common. Okay, so we're going to take out an A. So we're left with, well, if both of these cancel, we're just left with a B minus, and then A divided by A, both those cancels. We can't just leave nothing there. We're going to put a 1 there. And then let's check when we multiply back in. A times B is AB. A times negative 1 is negative 1A, or just negative A. That's your answer. You guys try number 12. Okay, 13. So here, 5x minus 13y. 5 and 13 have nothing in common, and one has an x and one has a y, so this one is prime. There's nothing in common. Okay, number 14, we have 18 and negative 48. What do they both have in common here? They have a 6. So use your calculator if you're not sure. Start dividing these and see, okay, they both have like 18. What are the factors of 18? Well, we have 3 times 6 and 2 times 9. So start dividing these by that number and see what's your greatest common factor. So 6. We have an a squared and an a. Remember, we always take the smallest with the exponent, so we have an a squared and a. A is smaller, so we're going to just take out an a. We have a b and a b, so we're going to take out a b. And then we have a c squared and a c cubed. C squared is smaller, so we're going to take out the c squared. What are we left with? Well, 18 divided by 6 is 3. And then how many a's do we have left? If we take out 1, we have just 1 a left. The b's cancel, we have no b's left, and we have no c's left, because they're both the same. So then we're going to put minus 48 divided by 6 is 16. And then A's are the same, so those cancel. The B's are the same, so those cancel. We have C cubed and C squared. We have 1C left, and that's your answer. So we can multiply back just to check. 6 times 3 is 18. A times A is A squared. And then we have BC squared. 6 times negative 16 is negative 48. ABC squared. And then times C is ABC cubed. Okay, you guys try 15, 16. So now we have 3 numbers here. 9, negative 18, negative 24. So a 9 goes into... No, it doesn't. See, I thought it was 9 at first, but 9 doesn't go into negative 24. Okay, so 3. 3 goes into all of these numbers here. So we can take out a 3. So could you take out a negative 3 because you have 2 of them that are negative? Yes. Okay, but I'm just decided just to take out a positive 3. Now we have r to the 8th, r squared, and r. What's your lowest exponent? R. So we're going to just write an r here. And then do you see how there's only 2 numbers with s's? This one doesn't have an s. We can't take out an s then. And then what are we left with? Well, 9 divided by 3 is 3. R to the 8th divided by r. We're just going to take out an r here. So we have 7 r's left, or r to the 7th left. Okay. And then negative 18 divided by 3 is negative 6. R squared divided by r. We have only 1 r left. And then that s too, because we never divided out an s. Negative 24 divided by 3 is negative 8. There's no more r's because the r's cancel out, r and r. And then we have an s squared. Okay. Then let's check. 3 times 3 is 9. R times r to the 7th is r to the 8th. 3 times negative 6 is negative 18. R times r is r squared. And then we have that s. And then 3 times negative 8 is negative 24. R times s squared is rs squared. It's important to check. So, I wrote it out this time. Because you want to just check to make sure that they match. Because it's easy, like, you see how I took out a 9 at first? And obviously I realized later I couldn't take out a 9, so I erased it. But maybe you took out, like, I don't know, maybe you took out an s or something, and you multiply it back, and you're like, oh wait, this doesn't have an s. I have to change this. So definitely make sure you check your work. That's really important. Okay, try 17 and then 18. Okay, so we have a 12, negative 36, and negative 6. A 6 can come out of all of these. Let's look at our a's. What's our smallest exponent here? A squared. And for our b's, our smallest exponent is a b squared. What are we left with? 12 divided by 6 is 2. If we take out 2 a's here, we have a third left. And then the b squareds cancel out. We have no more b squareds. 36 divided by 6, negative 36 divided by 6 is negative 6. A to the 4th divided by a squared is a squared. And we have b cubed and b squared, so we just have a b left. And then negative 6 divided by 6 is negative 1. A squared cancels out with a squared, and b squared cancels out with b squared, so that's it, just a negative 1. Okay, so let's multiply it back out. 6 times 2 is 12. A squared times a to the 3rd is a to the 5th. B squared, so far it matches. That's good. 6 times negative 6 is negative 36. A squared times a squared is a to the 4th. B squared times b is b cubed. That matches. And then a squared b squared times negative 1 is negative 6a squared b squared. So that's good. That means that's your final answer, that this is correct. Okay, last few. So number 19. Out of all of these numbers, we can take out a 14. Now we only have 2 g's. This one doesn't have a g, so we can't take out a g, but we can take out an h. And then what are we left with? If we divide 14 divided by 14, it's 1. We have a g left because we didn't take out a g. And then h squared divided by h, we have an h left. Plus 28 divided by 14 here is 2. And then a g. The h's cancel out again. 14h divided by 14h is just a 1. So if we have 14h times, or 14 times 1, it's 14. H times gh is gh squared. 14 times 2 is 28. H times g is gh or hg. You can always flip these around. GH and HG are the same thing, but do go in alphabetical order. And then 14H times 1 is 14H. And that's good. We checked it. This matches this, which means we did this part right. Okay, try 20. Now, out of all of those, the smallest, okay, notice how I didn't look at the numbers this time because this has a 5, a 1, and a 1. We can't take out any numbers. So we're just going to go straight to the variables. M cubed, M squared, and M. The smallest exponent is just that 1, M1, so we can take out 1M. And then out of our n's, the smallest one is another just n by itself. So M cubed divided by M, we have M squared left. And then our n's, we don't have any n's left. Those cancel out. Minus M squared divided by M is M. N squared divided by N is N. And we still have that 5. The m's here cancel out. M divided by M is just 1, so we don't have to write that. N cubed divided by N, we have N squared left. So let's check. M times M squared is M cubed times N, because we have that N there. M times M is M squared. N times N is N squared. And then plus 5M. And then n times n squared is n cubed. So you see how important it is. It's really important to check. This matches this. We're good. So we know that that's our answer. Try 22, and try 23, and we're gonna do 24 together. So 3, -9, and 15, they have a 3 in common. A cubed, A squared, and A, the smallest exponent is just A. B squared, B cubed, and B to the 4th, B squared in common. And then for our c's, we have a c in common. So what's left? So we have 3 divided by 3, which is 1. A cubed divided by A is A squared. The B squareds cancel, and the c's cancel as well. So that's it for that one. -9 divided by 3 is -3. A squared divided by A is A. B cubed divided by B squared is B. And then C squared divided by C is C. Plus, we have 5, the A's cancel, so we have B squared and C squared. So let's check. 3 times 1 is 3, A times A squared is A cubed, and then we have nothing else, so we're just going to tack on the B squared C, and that matches, so that's good. 3 times -3 is -9, A squared, B 3, and then C squared. If we multiply this next piece, 3 times 5 is 15. A, B to the 4th, C cubed, and that matches. So that means we did it right. So do all the ones that I circled on all of the pages, and then raise your hand when you're done.